right, let's get started. I do want to comment that it's been really interesting to see how repair, refurbishment, and remanufacturing is actually making a comeback, and how many companies are taking that into consideration, where I think for a while we just kind of throw everything away. I actually just, over last weekend, thanks to iFixit, was able to repair my son's MacBook Air and give it a new life with a new screen. That was pretty cool. All right, so quick introduction of myself. I am also a recovering mechanical engineer, like many of us here. Spent my career in semiconductor. I think one of the coolest things I did is I said, wait a minute, you can use semiconductor technology to grow diamonds, so I went and did that. And then worked on various types of software and consumer electronics. I'm now very happy to be helping a bunch of companies out here with building better products. Alan here, I've really enjoyed working with over the last couple of years. He's actually a double E. So we've got a mechanical engineering, electrical engineering rivalry here going. And Alan's really spent his career starting off in electronics design, worked for some of the leading companies in that space, Mentor Graphics, Synopsys, Cadence, more recently Siemens. And Alan, I heard that you spent 12 years at Apple and your wife thought you were crazy for joining.
Yeah, when I joined in 2005, it was kind of a risky proposition. I was hired by Steve Jobs and Bob Mansfield to really replace the design processes and flows they had for hardware engineering. And I didn't really know what the secret project was that they brought me in for, and come to find out it was the first iPhone. So it was a great experience.
So over the past 4 years, you've been working with the top electronics brands in the world. You've been working very closely with a lot of the executives there, CTOs and chief supply chain officers, engineering leaders at these brands. I do wonder, what's a recent trend over the last couple of years that you've observed?
Well, I think, we've talked about this throughout the day, but the bottom line is reducing the time to market and making sure you don't sacrifice quality, and really leveraging what we're capable of with AI and large language models now.
So what I'm hearing is companies, I think Zach was saying this, the top 3 things is speed, speed, speed. And we like speed apparently. And I'm wondering if you have a specific example, without naming the company of course, of where someone came to you and said, hey, Alan, we've got to reduce NPI cycle time, we want to improve quality, and we want to do this fast. Is there an example you can share with us?
Yeah, I think in the personal computer space, what we're looking at with this particular company is they wanted to reduce their design process time by 50%. And what ended up happening...
And by the way, this is a big company. So big, coming in and saying, okay, company. It was how many months was their existing NPI cycle time?
For about 18 months.
So they wanted to go from 18 to 9 in one shot.
That's right. And that's what ended up happening. In fact, it was a little less than 9 months from a process standpoint. And we're also looking at other metrics like quality and making sure that we're at least towing the line there. And so
what kind of quality metrics were they looking to improve?
I'm sorry?
What kind of quality metrics were they looking to improve at the same time?
They were looking in reliability in terms of a lot of different factors. So we're talking about thermal reliability, we're talking about power consumption, burn-in type of issues. Those were all different factors. And then, of course, the overall yield.
So they were looking to reduce NPI cycle time by 50%. Sounds like they succeeded. They were looking to improve quality. What I heard from you was these metrics by about 20%. And how did they do that? What kind of technology did you deploy, and how did that work?
So they started working towards digital twin, and that takes a while to build up. It's a phased approach, but really nailing down areas in the different domains that they could model the devices and make sure that they had what they needed.
So to be clear, this is the digital twin of the product, as opposed to maybe some of you have been working on digital twin of the manufacturing line, for example. So what are some areas? Okay, so put this together for me. Okay, so how does a digital twin reduce your NPI cycle time? What was actually going on in that company that was causing it to develop new products in 18 months instead of 9? What did you cut out? Where was the fat you cut out with the digital
Well,
twin?
they were identifying a lot of their problems in prototype, and that was probably the biggest area. So, what was happening was we were attempting to model more of the device earlier on in the process. You hear about shift left. This was taking it into even the architectural phase, having behavioral models of the architecture, then having models of the PCBs, of the chips, and not only being able to simulate those in different environments, but also simulate them with the applications and the operating systems that govern the function.
So you're saying there was a long prototyping process that was happening. They were building before, kind of the as-is state was, how many prototypes were they building to try to get
Hundreds.
Hundreds of prototypes.
Yes.
And in fact, they were able to replace some hundreds of prototypes with a digital version.
Yes.
And I mean, maybe you can dig into that a little bit more specifically in terms of first, what's an example of a prototype they could avoid? And then I actually have a follow-on question to that.
Well, I think, when you're trying to limit your prototypes, you would get down to looking for specific critical areas and not have to worry about everything. So the key is to be able to get the low-hanging fruit, be able to pick that off in engineering and not have to worry about it down the line. So you don't want to worry about it with your gurus that are involved in the design, and you don't want to worry about it in the lab. And so you decentralize your approach and you get more of your design capabilities and models upfront in your engineering.
Okay, so what were some of the issues they ran into? Because in a perfect world, I think every one of us would just create a perfect digital twin of the product we're going to develop and then just go right to PVT, right? Mm-hmm. So what are some of the challenges with a virtual twin approach?
Well, I think one of the biggest challenges is the data itself. If you don't have the right data or you have incomplete data, then you really have issues. You're working off too many assumptions, and you have to make sure that you're able to improve upon that process. So the data and accuracy data is key.
Maybe I'll just kind of one last question about that. I heard something about how if you have the wrong data, your risk actually goes up as opposed to going down. Maybe you want to dig into that a little bit?
Yeah, I think what ends up happening is that you have the wrong data, you're making assumptions, you go down the line, and then you're having to pick up those problems later on in the process. So you're definitely increasing your risk rather than mitigating it. All right, so Alon, have you seen teams improve their NPI process just by having better data?
Yeah, so I think the data you've been talking about is the data for the different components and the different models that go into the product itself. Of course, at Instrumental, we're looking more at the data that's coming off of the production lines. And I think what's interesting is we talk about the future and we talk about AI, but in fact, the company didn't always have all these functionalities. I was actually sitting down for dinner with a former customer, Marcel Tremblay, who was running hardware over at FLIR. And his objective, this was 7 years ago, was to build the FLIR 1. You guys can look it up on Amazon. It's actually a pretty cool product. I think every engineer wants one of these. It's a thermal camera that attaches to your iPhone. And he was told, Marcel, you need to develop this and get it to market in 6.5 months. The company had never shipped a product in 6.5 months, let alone now he's got to go and build this with Foxconn over in Asia. And what he realized was the speed of iteration was really going to be important, and that he needed remote access to what was going on in that production line. Of course, at the end of the day, and you can actually, I did an article with him for the Build Better, a little plug. We also have a Build Better magazine and Build Better on the website and all sorts of great interviews there. So I interviewed him about it. And, a key part of this was, flying over, I think we've talked about that earlier, is really important, but you can't really have your eyes on everything that's going on in the production line. And so by simply having that traceable data record, we heard Miles talk about this earlier, was enough to shorten that NPI cycle time down and reduce those iterations.
Yeah, so I mean, 6.5 months is really aggressive. And, we heard earlier that having large teams on site and traveling to the manufacturers is important from a craftsman perspective. But however, it's equally important that you're able to collaborate 24/7 and your teams can exchange data. Plus, if you have a smaller scale operation, like if you're in a startup mode or an SMB, you don't have that force that you can just deploy on site at the factory. So now that you have AI features, what are you seeing and what information is important, and how are you using that to shift left and get that information further up on the design process?
Yeah, so we talked a lot about that today. I mean, Anna started off in the morning. We had Judd and Miles talk about their own experience, and it really comes down to something that we talk about, which is engineering efficiency. I don't know that's something that folks have really been thinking about. I mean, in the software world, co-pilots are there to really turn engineers into 10x engineers, right? And so if you think about what you're doing with AI, is you're basically sifting through all of the chaff, right? You're basically, if you think about it, like the analogy would be, if I'm panning for gold and I'm sitting there in the river, I'm really just trying to get rid of all of the sand and, rocks and so on to get to those golden nuggets. And so the AI features are delivering the golden nuggets more directly to engineers. And we really measure this in terms of how do we do, for example, failure analysis in minutes versus days. Anna talked about that a little bit. How do we go and help teams put in preventive measures on the production line? So there's even this aspect of operators, right? So an operator is sitting there and conducting some sort of operation, maybe putting a part in or putting in some screws or plugging in a cable or what have you. And in the before world, the before AI, you could collect that data, and then after the fact, maybe a week goes by, you go back to the operator and say, oh my God, you just built a few hundred units and they're junk, and now we have to go and find and quarantine them. Well, the ability to do the inference at the edge at the operator station allows the operator to receive effectively corrective actions in real time, right? And so, I've walked into factories where we've got stations deployed that may have 100 of these AI models that are running. And so any little thing that the operator may be doing that could affect functional test or create an escape is caught on the spot. And that's something that we really needed AI for, because in manufacturing, there's a lot of natural variation that you're going to be fine with. And what you really want to catch is the things that are going to either affect your yield or your field quality.
So how have you seen prolonged failure analysis affect program schedule?
Yeah, so I think I'm going to wrap up with this because I did promise to be on time, Phil. I think one of the things that I underestimated, you all saw Anna's pitch around failure analysis. One of the things that I underestimated in this phase-gated approach of hardware development is how failure analysis effectively becomes the long pole in moving to your next milestone, right? Think about it. If you run a reliability test, if you fail some functional test, you're going to be waiting around for either your in-region team, your JDM team, your local California team to go and understand what the root cause is. And so my experience has been, or if it's happening in the field, let's say we're doing some beta testing with customers, we've got a field failure. We don't know. I mean, this is now DVT. Are we going into PVT, right? Or do we have to wait for these units to come back? Now the field testers have to ship those units back, et cetera. And so one of the key things is, if we think about program schedules, there's the prototyping that the digital twin solves. But I think having access to the data and having these AI insights on the data, having the correlations tool allows you to shorten. That's what everyone should really be measuring. I mean, how many of us are measuring the average time it takes to conduct a failure analysis and to get to a root cause? And how much program time is that consuming, right? So I think we can summarize here a little bit. I'll start real quick. I think Alan, and you guys should catch him later. We haven't had a lot of time to dig into it. Has been working on digital twin, which is something we haven't really mentioned today very much, specifically around the product digital twin, and with the superpower being, hey, now I can go and create some, hundreds of prototypes or hundreds of DOEs in seconds and get my answers and not have to go and find out, 5 weeks later in the lab that my DOE is a failure, right? I think that's the key takeaway.
Yeah, and I think, Alon, in terms of instrumental being able to provide using AI that correct information and shifting it left in the process is extremely valuable in decreasing that time to market as well.
Awesome. All right, Phil, we're gonna run this.
Thank you.
Run this show on time.